Hello, my name is Yakubova Lvina and I work at Huawei Advanced Software Technology Lab. And today I'm going to tell you how to add support for a specific subtarget to LLVM in just 5 minutes. This guide is based on my recent hands-on experience of adding high-silicon ARM CPU Kunpeng 920 model, also called as TSV110 support to LLVM. LVM has a unified format for determining the processor properties required for the compiler, which is called TableGen. For each supported architecture, .td files contain a description in a special formal language. All interactions between the TableGen description and the LVM backend code is provided by the generated .inc files that contain the C code. We will cover Arch64 architecture, so there is a file generate subtarget info.inc from build folder which contains information about our subtarget. As a result, the .inc file is included in MIScheduler descriptor in LVM target. Since you've learned about TableGen, let's move further through this step-by-step guide how to add a new subtarget. So, firstly, you need to edit your architecture-specific TableGen file. For us, it was arch64.td. In this file, you should add features supported by your CPU and include the file with your description of a model. Secondly, create scheduling categories. You can define them in the arch-schedule file. Then you associate these categories with actual instructions from the instruction info file. In subtarget-specific file, you should describe your processor features. For doing this, define sched_machine model based on information you have about specific CPU. It includes things like issue width, micro-op buffer size, load latency, and etc. Then you define processor resources which impact scheduling. And finally, you can link processor units and latencies to the scheduling categories which were defined on the previous step. Basically, after this, you are done with minimal module description. If you want to add more details in your module, you need to do instruction refining, which means overriding operations with more interesting processor features. In this case, you have to define a new sched_write and attach it to the processor units and latency. And finally, associate list of opcodes to the sched_write which you defined on subtarget level with the help of instrw. To conclude, that's all. Now you can build and check if everything is working fine. That's where LLVM test suite comes. The test suite contains a flexible infrastructure for building, running, and collecting benchmarks and test metrics. LLVM does not include the test suite by default, it has its own repository. The test suite is divided into several folders, which you can see on the slide. External suites contain support for running tests which can be directly distributed with a test suite, for example, spec benchmarks. CMake and the special lead test format are responsible for building, running, and collecting metrics. We use a few options to run benchmarks only and compile all benchmarks for a specific processor using MCPU option to test how our subtarget performs after tuning the model. The results for each test is displayed as shown on the slide. Test suite contains such metrics as compilation, execution, link time, and code size by sections. Results from different runs can be compared using the script included in the test suite. Another tool we used was LLVM MCA. It is a static performance analysis tool that uses information available in LLVM to generate analysis reports for a specific target processor. Important performance indicators from the reports are instructions per cycle, micro-opcodes per cycle, and some other useful views are resource pressure, dispatch statistic, and timeline view, which shows instruction states changes during execution. I believe now you have a general understanding of how to add a new subtarget to LLVM without wasting too much time on it and how to test the results of your work. You can use links from presentation to get more information about each topic. Thank you very much for your attention.